All right, welcome. Thank you for coming. Today I am going to, and I tend to move around a lot, so I'm just going to do this. How about that? Today I'm going to be talking about IronPython and a bunch of .NET tradecraft, so hopefully you'll be interested in what I'm about to say. This is basically a completely updated talk that I did at DerbyCon last year, and it's so updated that all the content is different. I guess it just has the same title. And I'm going to talk about IronPython, .NET tradecraft, and I'm also be introducing a type of payload that you can use for both post-exploitation or initial access that I've started coining BYOI payloads, so bring your own interpreter payloads, just because of the nature of this talk. And we're going to be covering a lot of ground, so I'm really just going to jump right into it. This is our agenda for today. I'm going to be going over some of my key motivations here in terms of like why I even do this in the first place. Some .NET framework concepts we sort of have to all get on the same page to completely grasp what I'm about to tell you. So I'm not going to assume everyone's a .NET developer here. So I just want to introduce some high-level concepts about the .NET framework, nothing to be scared about. Then we're going to be talking about embedding interpreters and engines, which is sort of the root of this talk, the key point of this talk. We're going to be talking about how to embed interpreters and engines to do really weird stuff and possibly evade some controls or EDR solutions. Then I'm going to be talking about the actual bring your own interpreter payloads, BYOI payloads themselves. Then we're going to be talking about how to actually weaponize just any .NET scripting language, really in general terms. You don't necessarily have to embed these languages within one another. You can use the provided, and that just got louder real fast. Okay, perfect. And we're going to be talking about how to use some of the built-in compilers to actually compile .NET scripting languages as opposed to embedding in them one another, which allows for a really quick weaponization. And if we have time after all of that, I'm going to also be demoing a tool that I've developed that sort of tries to bring together a lot of these concepts called Silent Trinity. And then after that, we're going to detection and questions and answers. So quick, who am I? My name is Marcello. I go by ByteBleeder on Twitter. I work for Black Hills Information Security. I've got a lot of sparkly papers on my wall, which some people say they're certs. And I've also written some open source tools over the years. I have no life, please send help. And that is my GitHub profile if you are interested in viewing some of the stuff that I've written in the past 5 to 6 years now, I think. So we're going to jump right into it. The main reasoning behind all of this really at the beginning was to try and innovate a lot of the PowerShell protections that were put in place by Microsoft over the course of the years. PowerShell has been all the rage over the past 4 or 5 years in terms of attacks and in terms of like offensive tradecraft, and that's steadily and slowly been dying. I tend to say that it's not really dead yet, just because, at least in my personal experience and the clients that I've been assigned to at Black Hills, we see a lot of PowerShell version 1 installed on a lot of endpoints. So you can switch back to PowerShell tradecraft in that case. And so it's not completely dead yet. So like on most red teams and most mature security environments, I can definitely say that PowerShell tradecraft is completely off the table and will get you detected in a matter of seconds. But in some organizations, it just completely still flies under the radar. So it really does vary. So I like to say it's in zombie mode right now because it's not completely dead, but it's still there. You can still use it. We're also going to be talking about some of the bad things about the C# tooling migration, right? So all of the PowerShell stuff that's been written over the past 4 or 5 years, we've been slowly, and the offensive community has slowly been migrating it all over to C#, right? And that brings a lot of operational disadvantages. And this is really what I wanted to address originally, was compiling stuff all the time on engagements really can be time consuming. And you can set up like continuous integration pipelines, which a lot of people have already done and stuff, but I guess I'm just too lazy for that. So what I wanted to do was shift back the paradigm from C# tooling back to PowerShell style-like attacks, because dynamic languages and scripting languages are the best thing you can use on a red team engagement, because they're flexible, and because of the nature of the dynamic languages, you can use built-in functions like eval and all of those built-in dynamic language functions to quickly prototype things and weaponize things. So it's a lot more flexible operationally in terms of what you can do in an environment. And also, I really do like developing weird tools in tradecraft. Whenever like something new comes out, I tend to find like the very niche areas of it. That's always sort of been my thing. I'm not exactly sure. And I'm stealing this quote from a friend of mine that I should really frame. The weirder you get, the harder you are to detect. And the more I think about it, the more true that gets. I love the way he phrased that. So before I talk about the actual engine embedding, we have to cover some high-level .NET framework concepts, right? So if you're familiar at all with .NET development, you probably heard a .NET assembly term thrown around a lot. But I guarantee you, if you start looking into C# or .NET, you'll probably hear this term almost immediately. And so we need to understand like what that is in order to completely grasp the rest of this talk, right? So a .NET assembly, all you really need to know, we're not going to be covering it in depth because I could be here, like I can do a talk on that just by itself, but all you really need to know, .NET assembly is a blob of precompiled code, okay, that any .NET language can interpret and execute. That's all you really need to know. We're not going to be covering the format of that because that's complicated. So the key phrase there, the key part of that sentence though, is that any .NET language can interpret and execute it. And that has some really interesting implications. So how do you go about generating a .NET assembly? A .NET assembly, you take any .NET language and you compile it, okay? And this is another, I guess, misunderstanding that a lot of people have, is that whenever we talk about .NET framework, a lot of people tend to associate it only with C#. C# is not the .NET framework. .NET framework is a set of tools and infrastructure and really a framework that you can use to build your own programming language. C# is just the de facto language of it, but it's not necessarily the .NET framework itself, okay? So I'm using C# here, an example, but you can replace it with any language based on .NET. So you take a .NET language, compile it, you'll get an executable, .exe, right? That executable is a .NET assembly. What's really interesting, though, is that if you take that same code, your C# code, and compile it into a DLL, that DLL is also a .NET assembly. So this is where things change from what you'd expect from native languages or unmanaged languages, as we call them in .NET development, right? So both this executable and a DLL that you generate from C# code are .NET assemblies. And again, like another important concept to understand is that .NET assemblies are not the same as native executables and DLLs. The format is basically completely different. So in the .NET world, we tend to say managed and unmanaged code, managed code being any code based on the .NET framework. Unmanaged code is stuff like C or C++ that's completely separate from the CLR and the .NET framework itself. Now we have to sort of go back to what I said earlier about .NET languages, because it's important to understand this, right? So the .NET framework is just a set of tools and infrastructure in place in order to build your own language, right? And there are a lot of languages based on the .NET framework. There are some that are officially supported by Microsoft, and C# is by far the de facto .NET language. So there's C#, but there's also PowerShell. PowerShell is a .NET language. There's also F#. There's also VB.NET. Then you can get into the weird mixed mode assemblies with Visual C++, which is just the crazy world to be in. But there are also third-party .NET languages, right, that Microsoft doesn't support, and these are really, really interesting. So there's IronPython, for example. IronPython is nothing more than a Python implementation on top of the .NET framework. So normal Python is based on CPython, which is based on C, right? IronPython is based on the .NET framework. There's also Booleang. So Booleang is, how many of you have heard of Booleang before? 1, 2, Okay, 2 people. That's pretty good. I've gotten less than that in other conferences. Booleang is amazing, and I'm going to be demoing a lot of the stuff that Booleang has because in terms of like, in terms of operational value, it's amazing. So I'm going to be demoing that. Iron Ruby is also in case you want to write Ruby based on .NET. There's also that option, but there are tons more, and I actually have a list at the end of these slides of all the .NET scripting languages that I found so far. And there's a couple based on Lua. It's just amazing the stuff that you find. So now that we've covered that, we have to a little bit talk about like why C# tradecraft is such a big deal in the first place, right? And the root cause really comes down to this function. This is a function. C# and .NET languages are reflective by nature, which means you can do introspection and a lot of cool programming stuff. Assembly.load is a magical function that accepts a lot of other parameters, but there's a bunch of overloads to it. But one of the overloads is a byte array. And assembly.load takes the byte array of a .NET assembly, okay, and then loads that completely in memory, and you can access all of the code that you've written when you compiled that .NET assembly, okay? So going back to what I said earlier, right? You have your source code, you compile it to a .NET assembly that generates an executable in a DLL. All you really need is to take the byte array, so the bytes, you read that DLL, the byte array, pass it to assembly.load, and .NET will just automatically load that into memory, okay? So assembly.load is essentially the equivalent of having reflective DLL and reflective PE injection built into a language, if that makes sense. So this is an extremely powerful function, both for developers and also for offensive tradecraft, right? So this is where things start getting tied together because of that, and because the .NET framework, any language based on the .NET framework can interpret and execute a .NET assembly, that also means that all of these languages are completely interoperable with each other, okay? They all can execute .NET assemblies, and what that also means is because they're based on the same framework, and I apologize if I keep saying .NET framework, but it's just inevitable in this talk. Because they're based on the same framework, you can also embed these languages within one another. So you can take IronPython and embed it into C#. You can take C#, embed it into IronPython. You can take PowerShell, embed it into Booleang, embed it into IronPython. You could just keep on going if you want to. IronPython actually has this thing where I've called it engine inception, where you can just take IronPython engines and keep embedding them one in another. You can get really, really crazy with it. So again, like, this isn't mind-blowing stuff because we've sort of been doing this for a while, and whether, like, if you're a pen tester or a red teamer, you probably used a tool that sort of did this in one way or another. And we're going to be talking about that in a second, but because the reason why all of the PowerShell tooling got migrated to C# in the first place was because that is just well, two reasons. One is because C# is a natural transition from PowerShell. If you know PowerShell, you sort of need to know C#. So from a developer standpoint, like, it's an easy language to just pick up and learn, right? So, but the second reason is, as of right now, all of the protections that Microsoft has in place for PowerShell are not built in to the underlying framework itself, right? They're not built into the framework. They're built in currently into the PowerShell runtime. So all you need to do to bypass all of that is to just jump to another .NET framework language. So instead of using PowerShell, you can use C#, right? So that's the easiest transition, but C# is a compiled language, right? And I think we've sort of been, I don't know, I think the offensive community, I think we've sort of been pigeonholed into using C#, but like, we can use all of the other languages that both third-party and supported to do the exact same thing that we've been doing with PowerShell, and in a language that might be even easier to code than PowerShell, right? So we can use IronPython, for example, and through IronPython, you can access the complete .NET API. So you can do the same thing that we've been doing with PowerShell, only in Python, And yeah, Python. I guess I'm biased, but I just like Python a lot better. And you can use Booleang and Iron Ruby. So this is really the meat of this talk. This is the key concept of this talk, is that we can just use a scripting language instead of a compiled language. That offers us a lot more operational flexibility during red teams, right? So it's not as small as I thought it would be. Okay, so thankfully I have this thing. So you have been doing this. If you're a pen tester or a red teamer, you've probably already done something like this without even knowing it. There are a lot of tools out there, mainly PwnShell, NPS, Powerline, which I have up here. There's a bunch of tools that essentially allow you to run PowerShell without the PowerShell executable, right? Have you ever wondered why that's even possible? Because the .NET framework, all the .NET languages are interoperable with each other. That means it's natural that you can take the PowerShell runtime and embed it within a C# binary. So all of these tools are doing exactly this. They're just embedding the PowerShell runtime within a C# binary itself. So here, for example, there's a concept of PowerShell run spaces and stuff, but we're creating a pipeline. We're embedding the actual PowerShell runtime within a C# binary. But you can also do the reverse, right? You can take C# and embed it in PowerShell, and a lot of tools did this one way or another. Add type, which is the built-in function to do something like this, which you needed to do for like call native APIs and stuff. From an OPSEC perspective, this isn't the best solution because it leaves files to disk. But like the PowerSploit stuff, for example, uses reflection and the emit API to actually build these functions on the fly in order to not leave traces on disk. But you can just embed C# in PowerShell. And the same thing with any other .NET language. And that's what I'm going to be talking about today. I'm going to be demoing a couple of payloads that I created to do exactly this. So when you start embedding third-party languages within other .NET languages, especially ones that aren't officially supported by Microsoft, you'll run into some common problems. And these are usually the problems that you run into. And you're gonna see some, especially if you take a look at the code, you're gonna see some common patterns that we use in order to take care of all of these issues. The biggest issue, not really the biggest issue. A lot of people say to me that this is probably the biggest issue, but I personally don't think it is. The embedded languages usually need .NET version 4.0 and above. There are exceptions, but this is usually the case. That's because the scripting capabilities of .NET Framework were introduced in 4.0 with the DLR as opposed to the CLR. The embedded languages are going to need some DLLs that are not installed by default. But since they are .NET assemblies, we can usually just call assembly.load on them and just download them from the internet, and you take care of that problem pretty fast. The required assemblies, they're not installed by default. But also, depending on the host language, you are going to have to resolve those assemblies on runtime. This is more of a problem if you're embedding the language within C# because it's a compiled language. If you do it through PowerShell, it's an easier way. You don't have to hook events in .NET or anything like that. And again, because of assembly.load, we can just load these directly in memory without ever touching this and remain OPSEC safe, right? So how do you about actually loading these required assemblies? This is more geared towards C#, but essentially there are events in .NET where we can hook, and you can add custom logic to the way C# goes about resolving those assemblies, okay? So the assembly resolve event in C# is the primary way of doing it, but there are a bunch of other plugins for Visual Studio and stuff that allow you to seamlessly do this within Visual Studio itself, like Costura Fati, using other techniques and a combination of other little tricks to do this. So these are, I'm not going to bore you too much with this because these are just like implementation details. So we're just going to skip ahead here and actually see like a demo, like some of the stuff that I've created. And you know, this might be a little weird, but it's all fun. It's good. So the first payload I'm going to demo here is IronPython. Okay, so we're going to be embedding IronPython within PowerShell. All of the host language that I'm going to be demoing today is always going to be PowerShell, so that's the language that we're embedding into. The reason for that is for demo purposes. It's a lot easier to understand, and I don't have to compile stuff all the time live, which is not fun. But IronPython, again, is just a Python implementation on top of the .NET framework, okay? The biggest issue with embedding IronPython, though, is that the module that it needs to execute native DLLs, so to perform pinvoke, which essentially allows you to call native functions, so Win32 functions, is a third-party module, and it breaks, completely breaks, if you try to do it in memory. So if the IronPython runtime is loaded in memory, and you try to call native DLLs through it, the module completely breaks and errors out. And this is a known issue on IronPython. Unfortunately, IronPython really isn't the best language to embed because of that, because it doesn't allow you the flexibility in terms of when you're crafting your payloads in order to call native APIs and stuff. So IronPython itself, and all of the code that I'm going to be showing you is available on that GitHub repo. So if you want to take a look at this either live or like right now or later, you can go ahead and follow along. There are two examples in that repository. There's the sharpsnake.cs, which is the C# version of it, and then there's invoke ironpython.ps1, which I'm going to be showing you in a second. IronPython requires 4 DLLs to run, and they're listed over there. 2 of them they have Microsoft in the name. They're not signed DLLs, but they're there to allow IronPython to hook into the .NET framework, okay? So I'm going to be demoing this payload for you right now. Okay, can everyone see that back there? I see a maybe from, okay, I'm gonna make it bigger. All right, that's probably better. Okay, so this is a PowerShell script, right? Inside the PowerShell script, this is gonna be awkward with this microphone. Inside the PowerShell script, there's a bunch of IronPython code. This IronPython code is essentially loading a assembly. This assembly is the internal monologue project. I don't know how many of you have ever heard of internal monologue, but essentially it's a really cool way of getting the local users or any logged in users, depending on your privileges, password hashes. And it's gonna just deflate it, load it in memory, all using IronPython, right? So the PowerShell script itself isn't malicious per se, because all that PowerShell can see is that you're loading a bunch of assemblies, the IronPython assemblies, the Microsoft scripting DLLs, the Microsoft dynamic DLLs. You're loading those in memory. You're calling load.assembly, which is that function that I was talking about. And then you create the IronPython engine, and then you spin up you actually execute the IronPython code, which I will do now. And there you go. So we've essentially executed an IronPython script, and this is the password for my local user here on the password hash rather of the local user on this machine. We've essentially spin up an IronPython engine within PowerShell. Okay, we've then executed the IronPython, the actual script, which is embedded in the PowerShell file itself, and then loaded an assembly through the IronPython engine, as opposed to PowerShell, if that makes sense. So in terms of what PowerShell sees, like it isn't malicious per se. It's just a bunch of assembly loading and a script execution, and nothing else. Okay, so as I said before, IronPython is great. And Python's fantastic and all, but unfortunately, from an operational perspective, it isn't the best because you cannot call native APIs. And we need to do that during red teams to do all the fun shellcode injection stuff and all of the low-level stuff that we usually do. Booleang, on the other hand, is much better for a number of reasons. One, it's very inspired by Python, which makes me like it already. It's essentially the love child between C# and Python. It's strongly typed. And the most important thing though is that it has the functionality of calling native DLLs by default, so native functions by default. It's built into the language. It's not a third-party module. On top of that, because of the way the IronPython, the Boolean compiler rather works, there are no calls to csc.exe, which means all of the Boolean code gets compiled in memory through an intermediate language, which is what .NET uses in order to actually execute on multiple operating systems. So in terms of OPSEC, this is probably like the best language. If you choose to like create one of these payloads on your own, this is probably the best language to do it in because it is truly OPSEC safe. Okay, and I'm gonna show you really quickly a demo on this. Oh, and I guess I can talk about that later. Why not? I skipped the slide. Okay, so I have, this is, again, like all of these scripts are in that GitHub repository that I had on the slides. But this is a PowerShell script called invoke jump scare. And I thought that was cute because, you know, Boolean, boo, but okay. So I have a bunch of shellcode in this PowerShell script. You don't necessarily need to put it in the PowerShell script. You can put it completely in the Boolean source. I just have it in the PowerShell script to make it easier for everyone to understand. So I have just a calc payload, okay? This is a shellcode for a calc payload in the PowerShell script. I then load the Boolean DLL, the Boolean compiler, and the Boolean parser. These are 3 .NET assemblies that Boolean needs in order to actually compile Boolean code, okay? And then I am reading the Boolean source code off disk, but that also can be put in the PowerShell script. You can literally just comment this, uncomment that one line right there. You can just comment this whole line here, uncomment it rather, and just paste in the Boolean source code, and that'll work too. So you can create a single payload as opposed to, you know, dropping stuff on disk and everything. And then initializing the Boolean compiler and executing the actual Boolean source. Now let's take a look at the Boolean source for a second, just to give you an idea of, let's see, what's Sublime? Yes, oh boy, that's small. Nope, wrong button. Hold on. Or not. Okay, well, I guess, you know, my Zoom broke, but it's fine. Well, you're just gonna have to trust me, I guess, on this one, but you can go view it on GitHub if you want later. Essentially, it looks a lot like Python, and we're just defining, on the top here, we're just defining a bunch of DLL imports, so like if you're familiar with C#, it's literally just a bunch of DLL imports. After that, there's a bunch of shellcode injection code. So currently this Boolean source supports like 3 injection methods. There's the QU APC method, if you're familiar with that one. And then there's the classic write memory, create remote thread, and then there's the wait for single object method. So there's 3 shellcode injection methods that you can choose from when you actually go to perform this, right? When you actually go to actually execute it. Let's go back to this here. Okay, so we're embedding Boolean, and now let's do the classic pop calc here. All right, so I loaded the PowerShell script. Ah, there you go. And sweet, there you go. There's calc. So just to recap here, because I'm trying to like whenever I present this talk, I just want to make sure that I'm actually conveying the information correctly, right? So we're embedding Boolean itself inside of a PowerShell script, and then executing Boolean source directly in memory, which injects shellcode. Okay, so that's essentially what happened here. And the reasoning behind this is mainly an alternative to C#, right? So instead, again, shifting that paradigm back to PowerShell style-like attacks, because with very few lines of code, you can modify this to basically pull Boo source code down from the internet and compile it on the fly using PowerShell, right? So this is easily weaponized that way. All right, so I should have talked about this before I showed you that, but Booleang needs 3 .NET assemblies to run, and they're listed on top of there. On PowerShell, it's really easy to load them. C#, you need to pull some of that event hooking that I was talking about before. And again, like these examples that I just showed you are on the GitHub repo. And there's a C# version of it and the PowerShell version of it if you're interested, so you can grab it off of that. Now another one, and this is a recent discovery, another .NET language that I discovered recently of mine, is ClearScript. Now ClearScript is extremely interesting for a number of reasons. One is it's a officially supported Microsoft .NET language, and it was literally made to add scripting capabilities to .NET applications. So ClearScript has its own JScript and VBScript implementation. Okay, so what's also interesting is that those implementations don't seem to go through the standard Windows script host environment, which means that it should by default, and again, like I'm not 100% sure on this, but I've examined the code and there are no COM calls to any of the classic COM objects that you'd usually need to do in order to start up the Windows script host environment, right? So it should completely go through that, unless like someone here knows if it actually does start up the Windows script host. So far, I'm not able to find any code that actually has any evidence of that, right? What's also really cool, though, is that ClearScript allows you to expose the .NET CLR to JScript itself. So you can just dynamically call .NET APIs from JScript from an embedded ClearScript engine within PowerShell. It gets complicated, but like it's you can just keep embedding these languages until you get the desired functionality that you want. So, and this is another demo real quick. And let's see here. So let's go to the invoke ClearScript. And again, this is on the same GitHub repo, so if you want to take a look at the code, feel free to. So again, there's just one assembly. That's another thing great about ClearScript. It's one assembly instead of 3 or 4. So we have one assembly here. We load it directly in PowerShell. Then we initialize the ClearScript JScript engine, okay? Or you could also use VBScript with ClearScript. So depending on what engine you want. The magic, sort of the real magic, happens down below because here we're calling what ClearScript's called extended host functionality. And that allows you to expose the .NET CLR to JScript itself, right? And we're also telling it to allow reflection. So you can just dynamically load assemblies from an embedded ClearScript engine that runs JScript. And then this is the actual JScript code that we're going to be executing, right? And you can see here from the first 2 lines, hopefully it's big enough, but we're essentially just it would be essentially of the equivalent of the using statement in C#. So we're importing namespaces in order to access the system.core, system.reflection, and system.interop services, which are the great like namespaces that we usually use for creating payloads and stuff because of the functionality that they have. And then we're just calling system console.writeLine in order to just print something from the screen in order to demonstrate that it does have access to the CLR. We're also calling getObject here, which allows you to download an SCT script and execute whatever function you define in an SCT script. So if you're dealing with subt's work and SCT payloads, you can just call getObject from within ClearScript, and everything just magically works as you expect. So I'm just going to quickly start up a simple Python HTTP server here on my side. Okay, so we got an HTTP server running there. And now, when I execute this, oh, yep, there you go. Wrong command. There you go. So, and from the output, you can see that we've also have access to the .NET CLR, right? Because we've managed to actually dynamically access .NET APIs from JScript within PowerShell. within ClearScript, if that makes sense. And we popped calc, so we successfully executed the SCT payload. Sweet. Okay. And again, like, this isn't exactly like revolutionary stuff, but again, it's about shifting that paradigm back from compiled languages to like PowerShell style attacks. So dynamically evaluating scripts and like creating your payloads on the fly, server side, rather than like setting up development pipelines and that kind of stuff. So, and essentially like streamlining your payload creation for rapid prototyping. And at the same time, like, because we're embedding these languages that PowerShell doesn't have any insight into, like all the defenses that the PowerShell runtime doesn't have any insight into, we're also bypassing a lot of protections. So like AMZ and all that stuff. So like it has a number of advantages, and it's also usually, at least in my experience, when I've used these, it's also really confusing for defenders when they go read this. They usually are just really confused. So, you know, it's sort of passive obfuscation. There's also a C# example of this that you can view in the GitHub repo as well. So if you want to do this through C#, you can do that too. And again, like, because of the interoperability of all these languages, you can just pick and choose which language to embed these engines in. And there you go. Yeah, I already talked about that, so there you go. And so I just talked about 3 languages now, right? There are a bunch of others, and these are the ones that I've found so far. There's Lua implementations on top of .NET, so if you're comfortable with Lua and you want to create malware with Lua based on .NET, you can do that. And again, like, you can directly call .NET APIs through these languages because they're based on the .NET framework. A really interesting one that I'm going to be looking into hopefully soon if I ever get time is the .NET WebAssembly project. And that allows you to dynamically create and execute WebAssemblies from within .NET, which I find to be quite mind-blowing. So I'm definitely going to be looking at that because that would be some interesting, I think, shenanigan opportunities in terms of like payload and malware creation. So that's fantastic. There's also IronPython 2, which I've talked about already. There's IronPython 3 is in the works. I'm hoping that it's going to be ready by like the Python 2 EOL, but considering it's not the same developers at all, it might not be ready by next year. And there's also Boolang. You can also embed the Jint project, just standard JavaScript. If you want to embed JavaScript within .NET, you can do that too. Excuse me. It would be interesting to see, I've not tried this yet, it would be interesting to see what happens if you embedded JavaScript within C# and then threw a beef hook at it. That would be interesting. I would assume it would break, but it would be pretty cool to like beef endpoints. I think that would be like pretty hilarious. So say you don't want to do any of this, okay? Say you're like, Marcello, like this is great, but I don't want to do any of this whatsoever. I don't want to embed stuff. I don't want to worry about DLLs. I don't want to worry about anything. I just want to rapidly create payloads that you can serve to any .NET machine. Well, Boolang delivers. So I got you, fam, when it comes to that. Because these languages are based on the .NET Framework, .NET Framework provides these languages a bunch of tools in order for them to quickly create compilers for those scripting languages, okay? So usually these third-party languages come with built-in compilers. So you can take your Boolang script, okay, compile it directly to a .NET assembly, and it'll just run everywhere directly. So, and it's a lot faster than installing Visual Studio, fumbling around like, you know, in the UI of Visual Studio if you're not familiar with. It's just Sublime text, some Boolang source, compile it, and you're good to go. And again, it's a .NET assembly, so you can embed it, you know, in HTAs or using .NET to JS. You know, your world's your oyster at that point. And I'm going to demo that real quick. So I have here, well, that's kind of sad. You know what? I'm going to close Sublime, see if maybe that works with the zoom. No, I don't want to save changes. There you go. Okay. Let's go over here. Well, this kind of sucks. I never know Zoom would be my dismay in this talk. Okay. You're gonna have to, again, trust me. But again, this is also in the same repo. So if you want to pull this down, it's pretty easy to do. So this is some Boolean source that essentially calls mini dump write dump. Okay, so it's a native API that allows you to dump process memory. And of course, we're going to be dumping LSASS because that's what we all want to do. And I just want to note that it's 29 lines of code, no Visual Studio required. You can even do this on like a Linux system server side if you wanted. And then you can couple that with embedding Boolean in PowerShell or C# or whatever, and pulling this down remotely, compiling it on the endpoint, and doing this like actually performing like some C2 and stuff. Like you can compile, there's a lot of flexibility in terms of what you can do with this, right? So once you have this script, how do you go about compiling it? So again, these languages usually come with a built-in compiler. In Booleang's case, there's an executable called boocc.exe. Boocc.exe is the actual compiler for this. So we're giving it the source of the Booleang file that dumps memory, okay? And then we're telling it, output it to an executable. By default, it outputs to an executable. You can have it output to a DLL. I'm going to run this, and there you go. Boo compiler starts up, compiles it. We're good to go. And now it should be on my desktop here. There it is. I'm going to open up PowerShell and run it. So membum.exe, the first argument, the only argument that it accepts is the name of the memory dump you want to put on disk. I'm just going to, I'll call it what. And it also helps that I start PowerShell up as administrator, because in order to do this, I need to be administrator. So I'll do that real quick. Oh boy. Well, you saw the command line, so I think you all trust me. So desktop. Okay. You know what? I'm just going to make this bigger real quick. 1 second. 28. There you go. That's probably better. I'm going to have it HIP. There you go. Dump to C HIP. So this is now a memory dump. We go to the C drive here, and there it is. So we've created a really quick Boolean script that you can just write in Visual Studio, Sublime Text, without the overhead of the development environment, anything like that. Just a quick script. You compile it, and it runs on any .NET endpoint, and runs on any endpoint with that .NET framework installed. What's really cool, again, about Boolean also is that if you don't reference the Boolean toolchain itself in your script, so if you don't import some of the Boolean compilers and that kind of thing, it compiles directly to MSIL, which means that it'll also execute on any version of .NET. So if you took this binary, put it on a Windows 7 machine with the .NET Framework version 2 installed, it would just run no problem. Okay, so it's a really cool way of just quickly prototyping scripts and operationally weaponizing stuff, at least in my opinion. Okay, and I already did this. So there you go. So how much, and I do not have time to do this because I think there's only 40 seconds left. But Silent Trinity is a tool that I wrote. You can find it at that URL there if you're interested. I have a big update for it coming, but as of right now, it has some pretty good functionality. It tries to wrap these concepts around a framework and around an implant tool, a C2 implant tool. So it attempts to weaponize some of these concepts a little more and make it a little bit more streamlined. The 1.0 update, which is on GitHub right now, has a lot of cool stuff. It has encrypted C2 comms, Booleang support. So there are actually Booleang modules in the version that's online right now. The tab complete is awesome, and it completes everything, which I always, that's a pet peeve of mine, so I put tab complete in everything. you can customize the check-in interval sessions, and there's now a help menu option, which helps. And there's a bunch of modules. There's a Mimikatz module. There's a bunch of stuff. So definitely, I encourage you to check it out if you're interested in this stuff. Version 2.0, I'm working on right now the next version of it, and it'll be client-server based. So if you have something like Cobalt Strike, if you're familiar with Cobalt Strike, it'll basically be implemented like that. So you have a client, a server. It'll be multiplayer and multi-server. So I'm hoping that it'll be also like an alternative to Cobalt Strike. I just have to work on it a bit more. Now, detection. This is where stuff gets a little hard, as usual. .NET, so things are getting better. .NET 4.8 has integrated AMSI support. Now, again, it's signature-based, so your mileage may vary on that one. And there's already research in place that allows you to bypass the AMSI support in .NET 4.8. Another problem is that there won't be, another problem is that the endpoints won't have .NET 4.8 installed by default. So we're back to the PowerShell problem where different versions of .NET will have the defenses in place and some won't. These are some links to defensive techniques that have come out in the recent couple of months, essentially, or just a year or so. It's pretty recent. Crab's ETW is an official Microsoft project that allows you to detect this behavior using a technology called ETW, which is built into the Windows operating system by default, based on C++. Silk ETW is also an awesome resource, and it attempts to try to detect this stuff. There's also been some awesome stuff by the Wover, if you're familiar with that Twitter handle, that he's put out about how detecting these kind of attacks. Luke Jennings at Black Hat 18 did an awesome talk. Memory resident implants code injection is live as well, which is a good resource for some measures against this stuff. Countercept actually did, Countercept is an MWR company. They actually did a blog post on detecting Silent Trinity itself. So you can definitely refer to that if you want in terms of how to create signatures and detect these kind of activity on endpoints. The biggest giveaway, though, in my opinion, is non-assemblies with not a file backing. And by that I mean if you inspect the actual app domains that the .NET processes spin up and see that the assemblies themselves don't have a file name attached to them, they're not on disk, that's probably a pretty good giveaway. I actually haven't seen a legitimate .NET application yet that actually loads assemblies via reflection. So I still have to find that, which is kind of surprising to me. And also the fact that, Booleang, and they're called Booleang and IronPython, is a pretty dead giveaway, which could indicate some malicious activity. So IronPython and Booleang are definitely something that you should probably watch out for in terms of the .NET processes if they're loaded in. And I already talked about this, and again, long-term goal of Silent Trinity will be to integrate a bunch of other stuff that I wrote over the course of the years. So you'll have one tool to do infrastructure automation and network pen testing. So it would be cool to have a single tool that did all this. Thank you. Appreciate it.